All right, we'll get started. Well, hello everyone. Welcome to the Integrated Modeling for Road Condition Prediction webinar. My name is Luana Brashears. I'll be facilitating today's webinar. This webinar is part of the Road Weather Spotlight webinar series sponsored by the Federal Highway Administration. As a quick reminder, at NOCO, we offer a variety of resources to support the transportation systems management and operations community. You can go to NOCO's website, so it's transportationops.org, to browse through links for TISMO resources and news. Previous webinar recordings and case studies can be accessed from there. So this webinar has been recorded and the recording is going to be available at NOCO's website as well later. And now just a few logistics for today's webinar. Again, we're recording this webinar and the recording will be available on NOCO's website. All the attendees are encouraged to stay engaged by using the Q&A feature for questions and the chat feature for comments. So these are both on the bottom of your screen. We have a question and answer session at the end of all presentations today. So if you have any questions, we encourage you to enter them in the Q&A area as they come to mind at any time. Also, you can feel free to enter your name, your agency in the chat box, and they say hello to all your peers that are attending the webinar today. Next slide, please. So this is a standard US DOT Federal Highway Administration disclaimer that just reinforces that product names may be used during the webinar, but the US government does not endorse any product. Additionally, views and opinions expressed in this presentation are the presenters only, and they do not necessarily reflect those of Federal Highway Administration. Now I'll hand it over to Michelle Neuner. She's a senior transportation engineer at Leidos, and she'll be today's webinar moderator. Michelle, it's all yours.
Thank you. Thanks everybody for joining the webinar for the Road Weather Spotlight on Integrated Modeling for Road Condition Prediction, otherwise known as IMRCP. My name is Michelle Neuner. I'm the Leidos Project Manager for IMRCP, the project featured in this webinar. I've been at Leidos for about 8 years, and prior to that, I was at Missouri Department of Transportation for about 13 years. I'm going to be the moderator for today's webinar. We're going to hear from several speakers today. The webinar will be kicked off by Jawad Paracha, who will give an overview of today's webinar theme. And we'll also hear from Kyle Garrett, the principal investigator for the IMRCP project. He'll walk us through all of the details of IMRCP, including a little background and history leading up to phase 4, how it works, what it can do, and what it takes to deploy it. Next, we'll hear from Bob Sanchez, where he'll talk a bit about the results of the evaluation effort of IMRCP during phase 4. And last but not least, we'll hear from both Scott Lucas from Ohio Department of Transportation and Lucy Kimbing from Louisiana Department of Transportation and Development. They will talk about their experience with using and testing IMRCP in their state. At the end, there should be time for answering questions from the audience, so please don't forget to type in your questions in the Q&A box. To kick off this webinar, I'd like to introduce our first speaker. Jawad Paracha is part of the Road Weather and Work Zone Management team in the Office of Operations at FHWA headquarters. He has been with FHWA for more than 12 years. Prior to that, he worked for 13 years in the Office of Traffic and Safety at Maryland State Highway Administration. Jawad manages this research effort for FHWA. Jawad, please take it away.
Thanks, Michelle. I would also like to welcome everyone to this webinar on IMRCP, an FHWA-sponsored research effort. Next slide. So extreme weather events, as you know, have a potential to significantly impact transportation safety and operations. According to National Oceanic and Atmospheric Administration Office for Coastal Management, in 2021, there were 20 separate billion-dollar weather and climate disaster events, with the total cost in excess of $145 billion. Making it third most costly year on record behind 2017 and 2005. So FHWA's road weather management program has recognized and sponsored research into this intersection of weather and Transportation System Management and Operations, TSMO, for more than 20 years. The trend over time has been to move from basic road weather research to closer integration of road weather information with the TSMO, and to be able to sustain safety and mobility during extreme weather events. So one related question that keeps coming up that we are trying to answer through this effort is, how would TSMO be different during extreme weather events if we had better access to improved information about current and future travel conditions? Next slide. So at a minimum, agencies, transportation operators and decision makers would have an integrated view of conditions on the roadway across the entire highway network. This would enable them to identify risks at particular locations, both considering present as well as predicted future conditions. So this detailed knowledge of network conditions can be put to work in decision-making for planning, response, and recovery during extreme weather events. And the ultimate benefit is the reducing the safety risks as well as sustaining mobility as much as possible. Next slide. So integrated modeling for road condition prediction, or in short, IMRCP, is intended to provide data and decision support for these kinds of extreme weather events. It gathers and integrates traffic and weather data and creates new set of forecast data for road conditions. So in essence, it provides tools for what-if operational analysis for various strategies. It also provides views of the data from the archives and from the near past to present and future operational time horizons. In short, IMRCP is a tool that supports TSMO and emergency operations in decision-making, as well as the after-action review of an agency's response to extreme weather events. With this, for more details on the tool, recent deployments, findings, I will turn it over to Kyle.
Next, we have Kyle Garrett. Kyle Garrett's a principal with Synesis Partners and has over 40 years of systems engineering and project management experience. In addition to IMRCP, he and his staff at Synesis Partners have been involved with road weather data systems such as FHWA's weather data environment, studies on weather responsive management strategies, and connected and automated vehicle projects. Kyle is a member of the Transportation Research Board Standing Committee on Road Weather. Kyle, you can begin when you're ready.
Thank you, Michelle. Next slide, please. So, and thank you, Jawad, too, for the introduction. The Federal Highway Administration started development of this IMRCP, integrated predictive system, back in 2015, with the intent of extending awareness of road conditions to support decision-making in operations. The modeling and the integration works in two directions, really. First, to bring traffic and weather events data into a common view of conditions, and second, to extend that common view from now into the future and back into the past. This is a complex problem. It involves getting real-time data, corresponding archives of data, generating results from a variety of forecast models, and both deterministic and probabilistic. Those cover things like atmospheric and road weather, hydrology, traffic, work zones, winter maintenance, incidents, special events, pretty much whatever you can think of. It's a lot of data to combine. It takes those and then combines them in order to predict future and predict the current and future overall road and travel conditions for use within, say, a TMC by the operators, by maintenance providers, and ultimately, perhaps by the traveling public. Next slide. So the sum of these capabilities isn't just extended awareness. That's good and well, but it goes far beyond that. With these broader and deeper views of conditions, decision-making becomes a whole lot easier. We can look at better informed decisions for controls like variable speed limits maybe, or ramp metering or access gates, deploying maintenance, especially in winter time, providing traveler information, or maybe even for the public at least changing their travel plans. Working together, operators and maintainers have a basis for cooperative responses to storms. They aren't working in silos. Operators with more informed control strategies and the travelers that are getting the better information can then make better decisions, smoothing traffic. All of that smoother traffic and informed decision-making then leads to improved safety and mobility on the whole. Next slide, please. IMRCP has gone through now 4 phases of development and is actually started on a 5th that we can talk about later perhaps. Phase 1 was a systems engineering study to look at the technologies that are available, what kinds of forecasting tools are already out there, and to put together a preliminary concept for how this could all come together. Phase 2 successfully developed and deployed the system in a sub-metro study area in the Kansas City area, working in cooperation with both the Kansas and Missouri Departments of Transportation at their Scout TMC. That succeeded in bringing together traffic, weather, hydrological, and operations data and forecasts. IMRCP 3 then extended that operation to the entire Kansas City metro area, added some more traffic modeling, and more finely tuned all the forecasts. It was really the first, what I would call, complete demonstration over an area consistent with a TMC. In phase 4, we got a lot bigger scale to things. We extended the time horizons for the forecasting. We added tools to do scenario analysis. We did 2 new study areas, both of them statewide, one in Louisiana and one in Ohio. The Louisiana one was intentionally supposed to, and in fact did, support evacuation type data for tropical storms. So a lot has been accomplished now in 4 phases of IMRCP. Next slide. So IMRCP 4 objectives were to deploy to a metro, regional, or state area to assess the improvements to public evacuation, emergency response, and extreme weather events such as tropical storms. That in turn contributed to the fulfillment of the EARS initiative, the Emergency Planning Transportation Data Initiative. We also deployed to a state, Ohio, for planning, monitoring, and post-event assessment of traffic management during adverse winter weather. In both cases, we were able to show how broader situational awareness can be focused for decision support in planning and response. Next. I want to talk briefly about transportation agency involvement. As I was going through the history of the project, I hope you heard that this demonstration, these deployments of IMRCP aren't really possible without a sustained and pretty intense involvement from the agencies operating over the areas that it's deployed to. In particular, in this phase, as I said, we worked with the Ohio DOT and the Louisiana Department of Transportation and Development. We'll be hearing from them a little bit later. Not necessarily in any order. Their involvement included things like identifying and provide access to resources like data, describing for us their particular agency practices so that we could incorporate those in the work that was going on. And very specifically to operations personnel. We spent a lot of time in dialogue trying to understand how a tool like this could be used, especially since, as we all know, there are a lot of tools already available to a TMC or to operations and maintenance personnel, both to support normal day-to-day operations, but specifically to support winter operations. We needed feedback and guidance on the system development. We don't want this to be something that Federal Highway or its consultants just gin up and then throw out over the wall and say, please use this. We really wanted it to be something that was pertinent, relevant, timely, and was working on real problems that might be out there in the field. The states also helped us identify additional subject matter experts. So for example, in one case in Louisiana, we wanted to get very, very detailed elevation data for the roadways. That's typically not something that comes from the normal federal resources, where we're looking at topology and not at a road network. So we were able to get together with people in the pavement maintenance group at Louisiana DOTD, who in their surveys, their annual surveys, had collected very, very detailed longitudinal and lateral profiles of the roadways in the state. Of course, we wanted everybody to use and to test IMRCP in operations. And so we'll be talking, as I said, about that later on. But it's, again, worth thanking everybody at those states for their participation in their time. And then, as we'll discuss later, we asked the folks at the state agencies to also participate in project evaluations. Next slide, please. So I want to spend some time now going into the IMRCP concepts. This will be primarily a discussion of how it works, some of the models underneath, and I wish we had more time for it. It's not going to be exhaustive, but it will give you a high-level view of things. Next slide, please. So IMRCP it is a big data system. It has not just a lot of models for phenomena on the roadways and in the atmosphere and in the waterways. It also has to support all of the data that goes into those models. So it uses mechanistic and statistical models, both for road weather, for traffic, even for hydrology, for streams and rivers that may, and for that matter, coastal areas that may impact or affect the transportation network. The predictions have to start then with gathering all of the current and, where applicable, the forecast data about the roadways. So we collect traffic data, events that are going on the roadways, work zones, road closures, road weather to the extent that road weather begins with the atmospheric forecasts that come from other sources, but IMRCP does its road weather forecasting for the pavement surface itself. Hydrology, we get, again, both data and forecasts, and then operations, maintenance, and event response plans. Because it is a forecast, or it's attempting to forecast traffic conditions alongside pavement conditions, we have to have information about intended operations, or about the extent to which an incident may still be going on the roadway. Next slide, please. All of this, of course, has to actually relate to the road network itself. And there's a lot of effort spent up front in an IMRCP deployment, asking questions like, what areas and roadways are critical in supporting the transportation system and TSMO, in this case in Louisiana, say, during hurricane events. So there was a multi-part process to go look at what kinds of data and opportunities, what kinds of operations would be taking place on the road network during that circumstance. So we started by looking at what roadways were actually being monitored in the TMC. We looked at what roadways then would be affected or brought in to play during a hurricane evacuation. And then, of course, we had to go build a model. So the figure on the right is a representation of all of the roadways that were included in that model. The colors are just a way of indicating that we included not just interstate roadways, but part of the national highway system through Louisiana, most of it, in fact, as well as a lot of state routes and even some parish routes and arterials, especially in the coastal parishes, where those become critical to getting folks out of the way of a hurricane. Next slide, please. So the system itself looks pretty much like any other big data application, any complex system. It has sets of modules, which at a very high level include things like collecting data about forecasts and about current conditions. Those go into a data store. That has a common configuration for data that are not just current, but which reach into the past and into the future. It also then has forecast models that build off of the data in the store that cover things, in our case, like the pavement condition and traffic. And then there are other modules specifically for alerting, for monitoring conditions as they are both gathered from the original sources as well as from the forecast, and then can create alerts of conditions for specific roadway locations or even for areas. All of that then gets put into a set of views and reports that the user can get from a user interface. All of that's available over the internet, over the web, and it uses a series of maps and other tools to access the data. Next slide, please. So I want to talk a little bit more detail about the forecasting components. Those are really the core of what IMRCP is building over all of the data it's collected. As I said, we get some forecast data as well as the current conditions from local and national authorities. So state DOTs, for example, are providing historic and real-time traffic speed data and operations data. National Weather Service and other NOAA sources are providing atmospheric weather and river gauge levels and forecasts. And then the National Hurricane Center is providing its own layer over the top of that for tropical storm forecast paths and intensities. IMRCP pulls all of those together then to forecast the roadway conditions, specifically the speeds and the pavement surface conditions. What may be a little different is that IMRCP also conflates all of that data at the level of individual road segments so that you get a fully integrated view of road conditions across the past, the present, and the future. This goes down to the level even of being able to distinguish at grade segments from bridge segments. The elevations are included as part of this. Next slide. With regard to the road weather condition predictions, IMRCP uses a modified version of the Environment Canada Metro model to assess current pavement conditions and to forecast them. That's been modified in IMRCP to keep track of the rain and snow accumulations, the melting that's going on over time. The measurements and statistical analyses then form a basis for the initial estimates of the conditions. So we take advantage of all of the road weather information that comes from agency sensors. It's gathered up in the case that we're using into the weather data environment and then rolled into IMRCP. We use a kriging analysis to estimate conditions on roadways between the sensor stations. In the northern states where winter conditions are prominent, we get very, very good representations of the initial conditions. IMRCP then performs all of these metro time-dependent energy and mass balance computations and currently predicts pavement conditions out to 12 hours ahead. That could be extended and probably will be in the next phase. IMRCP then applies those pavement condition predictions or can be used to apply them to winter maintenance scenarios. Next slide. Traffic condition predictions, and we'll get into these a little in more detail when we talk about the tropical storms. It uses machine learning models to forecast future traffic speeds. Those take into consideration historic weather, event, and traffic speed data on particular road network links, and they're adjusted then to the real-time speed and incident data. We trained the machine learning to 2 years of historical data with then updating it monthly as we get new data to add to that. That training is applied to every single road segment in our network. What we get out of that are near-term 5-minute predictions of speed for each of those segments out to about 2 hours ahead. Our experience has shown that forecasts beyond 2 hours aren't able to take into account current conditions very well, especially when it relates to incidents that are either underway or may actually occur in the 2-hour forecast window. So we don't go beyond that. In the case of Louisiana, we then further trained the models to tropical storm events. That gives us 1 hour predictions of speed out to about 8 hours ahead during tropical storm conditions. Next slide. I also want to spend some time talking about IMRCP interfaces. Next slide, please. As I mentioned earlier, IMRCP uses a web-based user interface. It has essentially 3 main components to it: a time variable map, just like any other ATMS or a network monitoring system. It allows you to create reports and data subscriptions. And then it also has scenario-specific decision support tools, and we'll talk about each one of those in a little bit more detail. Users of the system have specific unique login credentials. They have profiles that they can keep so that we keep track of their current way of looking at the system, and they get their own reports and subscriptions. There are wizards and online documentation that help users navigate the system, especially for the scenario analysis and reporting. Next slide. So here's a view of an IMRCP map. If we had time and I didn't get so involved in detail with it, perhaps we could have done an online demo, but we're just going to walk through a couple of things here. The maps really are for providing situational awareness of road network conditions. Now, when I say that, that's not just current conditions. It can be extended into the past and future as well, and we'll talk about that a little bit more. It combines those road network views that perhaps all of you are used to seeing in a 511 system or on an ATMS, but it overlays all of that with regional weather maps. And then we also provide layers for the roads and for events. All of that is user selected. You can see in the figure that right now we're looking at the pavement state over our model, our network in Louisiana. This happened to be back in last April and pretty early in the morning. So you can see that a lot of the roadways, most of them in fact were dry, but some were wet and some actually were just showing dew. It gets so humid down there that that time of year you can get a lot of dew on the pavement, even though they're wet, even though it hasn't rained. So those are user selectable and everything can be overlaid. The events and alerts can be displayed on top of all of that. Data for any location that you might want to pick, in this case, say on a roadway, you can click on it and you'll then get a pop-up that shows you all of the detailed conditions on that roadway, as well as in the general area. Users can save the map preferences so that you don't have to always be adjusting which layers you wanted to see or what zoom level you wanted to see on the map. All right, next slide, please. I mentioned time-based viewing of the data. This is perhaps one of the more powerful features of the system. You can travel in time, if you will, using these controls. By default, it's always going to come up with current conditions, but you can view conditions 5 days into the future and 5 days into the past. That supports planning if you're looking into the future and after action reviews if you're looking into the past. And of course, it has very typical little calendar and time controls for doing all of that. Next slide, please. Reports and subscriptions are ways of getting data out for offline analysis, or for that matter, even to tie into another system. It is possible to create a subscription and have data extracted of the traffic and the pavement condition forecast so that you could put those in on a map in a different place or do detailed analysis offline. The reports and subscriptions are set up with a little widget, a wizard, and then you can either choose to select them as reports or subscriptions. The subscriptions are just recurring reports, and you can see then that when you view them, you get a list of all the reports that you've created, the subscriptions that are active, and then whatever files or results may have been generated by those subscriptions. I myself have at times had dozens of reports and subscription results queued up. Next slide, please. One of the new features in IMRCP4 that we don't really have time to get into has to do with scenario analysis for decision support. There was a desire, especially when looking at tropical storm conditions and the kinds of operations that have to go on during those, as well as perhaps in more traditional winter weather situations, to be able to do what-if analysis. So you can set up a scenario which describes a set of actions along a set of roadway segments. Those actions might be things like changing a speed limit or closing a lane. Perhaps it was opening a shoulder lane if you're going to do hard shoulder running. For maintenance purposes, you can select to plow snow at certain intervals or even to apply pavement treatments. And then we give you a 24-hour window for that scenario. You can then save that as a template if you want, or run it immediately. When you save it to be run later, then the weather and traffic inputs are based on conditions at the start time when you want it to run. So, for example, I could run a scenario today to look at conditions as they would be expected from other forecast tools to exist in 2 days, or maybe overnight tonight when I know we're going to get some rain where I am. Those runs then get queued for offline analysis. And again, you review the results on a map. In this next phase, we're going to be exporting those to a report as well. Next slide, please. So it's important to talk about applications, and I want to step through two particular ones. We'll first be looking at a set of winter storm use cases, and then we'll be looking at some tropical storm use cases. So let's go ahead to the next one. So winter conditions, as we all know, are complex operational challenges, both for operators, for the maintainers, and for the travelers. Travelers want information about conditions along their planned route. And of course, then depending upon what decisions they make, they can create or they can help mitigate the traffic consequences of the storm. Winter maintenance crews, they plan that winter maintenance crews plan to reduce that impact based on the forecasts, and might use a winter maintenance decision support system, but also adapt to conditions on the roadway. Operators in the TMC, of course, are monitoring conditions as the storm comes in, as things get better or eventually improve. In some cases, they may be using strategies like variable speed limits to help slow folks down so that the traffic consequences, or at least the safety consequences of the storm, can be limited. They may also, of course, be putting messages on road signs through smartphone apps sent out through the media. The gist of all of this, of course, is that we believe that IMRCP can assist in the event planning, the response, and even in the reviews of these kinds of events. Next slide. To do that, IMRCP has a lot of various uses depending upon which stage of the event you could be in. Obviously, it brings together a lot of weather forecast information, and so you can monitor the forecasts, as I mentioned earlier, starting about 5 days out to see how things are changing. It also adds to that pavement condition predictions. You can use the scenario analysis tool. Again, it's not a maintenance decision support system, but it can provide a simplified view of treatment plowing analyses. It's going to give you traffic predictions as you get closer and closer to those storm events. You can do operation scenario analyses. Some states, as we'll hear in Ohio, have variable speed limit that they can apply during these kinds of events. You can also do operations and condition monitoring while the event's going on, and of course, after action reviews. Next, please. So this is fun for me. I'm going to walk through a winter storm that we saw this year in Ohio, where IMRCP was deployed. And this was a significant storm, both in Ohio and elsewhere. It covered pretty much everything east of the Rockies, was affected by this at some point. The Weather Channel named it Izzy, which I have a hard time saying with a straight face, so I'm just going to call it the storm. But in Ohio's case, this storm had come off the plains, dipped south and down into Kentucky and Tennessee, and then was coming up into the Northeast. So from Ohio, this is a storm that did not affect the western part of the state as much as it did the eastern part of the state. This is back in January 16th and 17th. The 16th was a Sunday, and the precip forecast, as you can see here, as IMRCP displays it, was going to be starting on Sunday evening, very late, and then carrying over into Monday morning. IMRCP and its pavement condition forecasts were showing accumulations across most of Ohio. There was some slushy conditions and icing conditions, especially in the across the middle and the eastern part of the state, up towards Akron. All right, next slide, please. I want to walk you through what this looks like then as we went through that storm. Updated forecasts called for even slightly worse conditions by Sunday evening. That traffic speed forecast that we made going into that showed that even on a Sunday evening, traffic was going to be slowed just because of the weather conditions. In this case, traffic speeds were going to be down 30 to 45 miles an hour, even on the interstate highways, pretty much everywhere that it was snowing or we had mixed precipitation coming down. Next, please. So as I mentioned, Ohio DOT has a variable speed limit corridor along I-90 near Lake Erie because of the lake effect snow. And some of you will be familiar with that. It's been there quite a few years. This is not anything that we caused to be created. And I have to say, what I'm going to show you is pretty much an after-action review. The folks there in Ohio, as Scott Lucas will talk about later on, had IMRCP available, but operations on that corridor pretty much take care of themselves. Recognizing the conditions were going to get worse, from the statewide TMC, they started reducing the speed limit along that corridor, even on Sunday evening. So by around 9 p.m. on Sunday, they dropped the speed limit from 70 to 50, 3 in the morning. Conditions had gotten bad enough that it went down to 40. And then during or just prior to the morning commute, and this corridor is up to the northeast of Cleveland, it was dropped to 30 miles an hour. Next slide. So here's two views of the Monday morning commute. On the left, we have the forecast as of the prior evening. This is a weather forecast from the National Weather Service and pavement forecast from IMRCP. And as you can see, the storm has kind of moved out of the central and southern part of the state. There's still some snow showers predicted in there between Cincinnati and Columbus. But the bulk of the storm has moved off to the east at this point. This is the wraparound of the comma head of the storm. What you see on the right then is what was actually seen on the precipitation radar, and again, the very near real-time IMRCP monitoring of the pavement conditions. They're pretty consistent. And this is good news for all of us working on the project. I should mention that the pavement conditions that are shown here did not include the effects of any treatment or plowing. We were not able to get the snowplow data with Ohio. So this is an estimate of how things would look if in fact there weren't any treatment. Next slide, please. We also need to talk about the traffic forecast for that Monday morning commute. So this again on the left is the forecast conditions at about 7 a.m. Again, this is a forecast as of 5 a.m. that morning. So it looks a little different than the one you just saw. You also notice that rather than showing pavement conditions, this is showing the traffic forecast. And we're looking at the corridor there to I-90, where we see a lot of red and orange between Cleveland and the Pennsylvania state line in particular. Again, the forecast proved to be pretty good. Looking at the actual conditions as they were measured in the field and the TMC, we see that there pretty much were slow conditions everywhere that had been forecast, and that even the snowfall intensity was pretty much as forecast. Next, please. So then looking again back at that VSL corridor, what we saw was that as Monday went on, conditions improved substantially. There were a lot of snow showers for pretty much the rest of the day. The view in the map is actually the next morning, the 18th, for the commute, and you can see that traffic on 90 is back to normal. There's no snow coming down at that point. The TMC had then reversed the speed limits, and at midnight on Monday, at midnight, yes, I think this is midnight, or no, this is noon on Monday. The speed limit was increased just a little bit to 40 miles an hour. And then by Tuesday, overnight and morning, had gotten raised back up to 70 miles an hour. Our conclusion from this was that our forecasts of traffic conditions were pretty good, and we're able to take into account that VSL use on the corridor. Next slide, please. So we're going to make a big transition here and talk about tropical storm use cases. The figures on the right are from Hurricane Ida, which we'll talk about at some length, showing both the storm as it's approaching and about to make landfall, and then some of the subsequent flooding that happened in and around New Orleans. It was not nearly as bad as it could have been, and we'll get into that. Transportation systems like your TMCs and even the field components play a critical, but it is a supporting role in tropical storms. And that's true both in planning and in response and in recovery. The long view of transportation systems and tropical storms is that we want to be able to design for resilience such that the facilities and their operations are maintained at as close as we can to design conditions throughout those events. Now, in practice, how much of that's achievable is a different matter. Event planning, once you get past that design and resilience effort, revolves around supporting essentially the emergency operations, particularly for evacuations and whatever other preparations that need to be made. It may be that you can pre-deploy some assets for response and recovery. So it's a support role. It's the Emergency Operations Center and emergency personnel, state police or highway patrol that are really in charge, if you will, of traffic operations during that part of a tropical storm. The storm response, that is, while the storm is coming on shore, is really all about just monitoring and trying to support emergency response to the extent that even they are able to get out there as a storm is ongoing. And then, of course, the recovery phase focuses on restoring service, assessing the damages, clearing the roadways, restoring all the traffic controls, and in some cases, even reconstruction if there's been significant damage. Next slide, please. IMRCP, again, has several potential uses here. It can provide information and tools to support in all of those phases. The situational awareness capabilities support the situational awareness capabilities support the forecast and environment monitoring as the storm progresses. The traffic models can predict conditions to assist in planning for evacuations and operation decision support. The scenario analysis tool might be used for assessing weather responsive strategies if you were able to use them, like VSL or even lane use. Maybe we're going to open shoulders. We might have to close roadways if they're leading toward rather than away from flood-prone areas, and even contraflow if it gets used. The framework could also be used in the recovery phase to provide asset and operations monitoring, particularly if you can get enough data from the field to support it. And that would apply to road conditions, potentially even debris and closures. Next slide, please. In building up a model to support tropical storm uses, we of course have to look back at history. We want to talk about recent tropical storms in Louisiana. And for those of you who are not from the Gulf Coast states, this may be a good overview. Louisiana for years really was not that impacted by tropical storms. After Hurricane Katrina and Rita back in 2005, it was quite a few years before, in 2011, before there was even another hurricane affecting the state. Isaac in 2012 was very notable, Harvey in 2017, and then they really had a run of bad years. 2020, if you remember, just a couple of years ago, was particularly bad. There were 6 hurricanes, tropical storms that affected the state that year, and we'll talk more about that. If you look in the figure on the left, down in the corner, it shows the paths of storms that went actually over or very, very near to Louisiana and affected traffic and water conditions across the state. And then, of course, in 2021, we had hurricanes Ida and Claudette. There have not been any hurricanes that have significantly affected Louisiana this year, which is a real blessing for the state. But to be honest, it would have helped our project to have had a little bit more bad weather there. But we'll go with the blessings for Louisiana and try and make up for it with other data. All right, next slide. So I want to talk about the traffic models. We used the data from all of those storms in 2019 and 2020 to build traffic models for tropical storms. This is not something to be taken lightly. And for those of you who are knowledgeable in this area, I hope you can appreciate that we're stepping into a gator-infested swamp when we try to talk about this, but bear with me. We think we've got something to say about this. So we built a traffic model that has 3 major machine learning components, and then tested it, or rather trained it against all of those storms that we had had. The first component is a support vector machine model. It predicts whether traffic on a particular link will be influenced by a storm on a particular day. And then once we've identified that, we use a Markov chain model for predicting storms on affected links within a given period in that day, and a time series model for predicting the actual speeds based on real-time observed traffic speeds. Now, obviously, that is something that happens only in a very short time ahead or beyond the current time, but we were able, again, for tropical storm conditions to go back and look at historical data to do that. So this figure actually shows on the left the observations of impacted road segments on the interstate network in Louisiana during Hurricane Delta. Hurricane Delta was excluded from our training data set so that we could use it as a test of the results. The map on the right shows our predictions one day before landfall of which road segments would be impacted. And as you can see, we have some road segments. In fact, the majority of them we either predicted or were conservative and saw that we might have an impacted link shown in red, where perhaps that didn't actually occur. In the details, this is because, as the guys will tell you, every hurricane is different. No two paths across the state are identical. So even though we may have had 7 or 8 or 9 hurricanes to train against, the paths of each one of them are so distinct that we're looking for general patterns more than we are for very, very precise data across all the links in the network. This is a pretty good result. Next slide, please. We also looked at what that meant through time as the hurricane approached and then went past, over and past the state. So here we're looking at two sets of forecasts rather, over time of what the speeds would be in a particular location. This happens to be eastbound I-10 near Lafayette and kind of on your way into town. So for Hurricane Delta, the data on both the plots are shown as the blue line, the observations. On the left, we did what we call a one-shot forecast. It's well ahead of that based upon the hurricane path and predicted landfall location. And as you can see, we caught both the evacuation slowdown in traffic at that location. It's there about 20 hours in from the time that the simulation was started. Then we also caught, interestingly enough, the return traffic flow and the speed reduction that comes from all of the traffic trying to get back home after they've made their evacuation. On the right-hand side, we have a slightly different set of models that were doing 6-hour real-time updates of what the predicted landfall and path would be. And again, the results are similar. We caught, as shown with the red dotted line, we caught the evacuation piece and the return piece both as well. Next slide, please.
Kyle, I'm sorry to interrupt the flow of your presentation, but
That's all right.
Scott is going to have to leave the webinar a little sooner than initially
Oh,
thought.
yes.
So I would like to give Scott the chance to maybe just tell a little bit about his experience using the IMRCP system in Ohio DOT.
Okay.
Yeah.
Well, let's do that. I'll come back to Hurricane Ida in a minute. Do you want to,
Okay.
We don't need to put up any slides for him, I don't think.
No, I should be fine, Kyle, but thanks anyways.
All right.
Yeah,
Thanks, Scott.
No problem. Thanks, Michelle. Like Michelle said, my name is Scott Lucas. I'm with the Ohio Department of Transportation, and I'm a snow and ice coordinator there. And I kind of came late into the IMRCP program, working with Kyle, and but got a chance to learn a lot about it. Things that kind of really stood out to me that really did, like as a slider feature that I know that Kyle talked about, was be able to go back in time and kind of look at what had happened as compared to what was forecasted. And to do those comparisons, we have DTN as our weather forecast provider, and we have Weather Century Online, which we use for weather forecasting. So it was kind of an extra tool that I kind of like to use a few times to kind of check on how those two kind of balanced out with one another. So a lot of good things that way. But the other thing is that we did have a little bit of a discrepancy on that one storm that came through there in January, where it came through and some of the models were predicting snow in the areas where we had some freezing rain at, which it is just a very few degrees difference in that, and temperatures and different air strata. I don't know how those things formulate. So it is kind of very difficult to predict. But the one thing that's nice about the model is it's learning, and it's getting more and more accurate as time goes on with more data input. And as Kyle said, we weren't able to really give it any information from our GPS AVL program, but I think with that, along with other learning models and things like that, and more data input, I think it would definitely increase its accuracy in that too. It also had, like I said, a lot of great information that we could kind of look back and forth on with our VSL corridor up there on I-90 in Northern Ohio. And it was kind of nice to be able to look at that and see how those interactions happened between what was predicted and then how the speeds actually reacted to that, the weather event that came in. We do monitor it. We have ARWA stations all up and down the I-90 corridor with visibility sensors. And we also have cameras. And as Kyle also said, we also use our TMC to monitor that. So they look at it directly. It's not automated. It's always manned, and for the decisions on that. So, but like I said, we did enjoy it. I look forward to possibly able to use it some more and look at different things. We had some other folks that were looking at for other different situations in the past and how different actions that they did on the roadway and how the roadway reacted to it and the speeds reacted to it according to like levels of effort. We also have our own system where we utilize to kind of critique our snow and ice removal activities through our speed recovery. And meaning that we look at how when a storm comes in and a traffic speed drops below a certain mile per hour, what expected speed limit should be at that time, or expected speed should be at that time, is when our kind of event starts. And then once the snow stops and on the winds die down, we have a recovery time. We try to get our guys to be able to get the roads back to where the speed increases. So we're using just the evaluation of the driver to be able to evaluate the road conditions as their perception of road condition. And using, once again, IMRCP and looking at that as how our results are coming out with our critical success factors on our snow and ice recovery was kind of an interesting thing to do as well. But that's about all I have. I really appreciate the chance to be able to look at the program, though. Thank you.
Thanks, Scott.
Yep.
If anybody has any questions for Scott, feel free to put them in the Q&A, and I can always follow up with him afterwards and provide answers for you guys.
Yeah, I have no problem with that, and I'd be happy to email, or you can email it to me as well. I think my email address is probably in the system here. So I'm happy to answer any questions. Thank you.
Thanks, Scott. All right. Kyle, do you remember what slide you were on?
Yeah, more or less.
Yeah.
There you go.
There
That's
we go.
it. All right. Well, I love talking about this stuff, and I've got a few more on tropical storms, and then we're going to transition into talking about the evaluation. With respect to cases that we had to evaluate, IMRCP was up and running in Louisiana only just as Hurricane Ida came on shore back in August of 2021. Some of you may remember Ida grew very, very quickly from a tropical disturbance to a Category 4 storm in just 66 hours. That is not very long at all. And there were evacuation orders that went from voluntary to mandatory in less than 1 day. That's just not a lot of time to react. What some of you may not know is that each parish issues its own guidance. And then the city of New Orleans has guidance, 2 sets for areas both inside and outside the levees. There was not enough time, even though Louisiana has very complete and sophisticated contraflow plans, there was not enough time to implement that. Traffic, of course, was congested at lots of points along the interstate network, especially during the evacuation. Luckily, there were very few direct fatalities, but there was some significant damage from wind, surge, and flood in Louisiana, primarily bridge and roadway damage. Interestingly enough, the interstate highway service was restored in less than 2 days from that storm, and that includes debris clearance as well as just doing the inspections. Next slide, please. So to give you some idea of how this all came down, we put together one graphic that cramps an awful lot of information in here. What we're looking at is the time across the bottom in days, of course, with the calendar day, and then the maximum wind speed, which is associated with the hurricane or tropical storm category. So between the time that this was simply a tropical depression to the time that it was declared expected to be a major hurricane was just not very long. That occurred on, what was it, about 10 in the morning, I think, on the 27th of August. Only after that, of course, can you make a decision as to what to do about it. And the local policies and procedures were such that there was an announcement from the mayor of New Orleans that afternoon that there simply wasn't enough time for a safe evacuation. So areas outside the levee would be under mandatory evacuation, but anybody inside the levees, too hard to get out. And there was no time to deploy contraflow before the storm was going to be on shore. It takes time to get resources out there and to get all that set up. So nominally, this storm happened so fast that you would have to start the phase 1 evacuation of folks out in the coastal parishes before we even knew that it was going to be a major hurricane. And then, of course, it grew very, very quickly in the last 24 hours, especially in the last 12. Came on shore as a very, very near Category 5 hurricane. And then that was about, I think, 5 hours of tropical force winds before the eye wall comes on shore. And then, another 12 and it's out of Louisiana. So we want to take a look in the next slide at least one view of what we were seeing. And this is all post-event analysis. But we did generate, of course, traffic speeds across all of that network as the storm was approaching and coming on shore. So this starts at actually midnight in the morning of the 27th. There's you can see the dip there in the 28th that corresponds to the evacuation. This is for a particular westbound segment on I-10 over the Atchafalaya Bridge. So these are folks that have come from either New Orleans or Baton Rouge and are trying to head west over to Houston, or at least to the western part of Louisiana to get away from the storm. And the forecasts, these are a series of 2-hour forecasts stitched back together so that we can see it over the entire period of the storm, tracked very, very well. Next slide, please. So for future, the system is still monitoring tropical storm conditions. If one were to occur in what's left of the season this year, these are the kinds of questions and things that we would be looking at, and certainly for the next phase of IMRCP. As we all know, not just from Ida, but even more recently from Hurricane Ian in Florida, storms are getting more intense faster. To the point where it's even difficult to plan and prepare. And that includes even things like what the path of the storm is. The storms are becoming more and more predictable, at least of a certain size. And that caused a lot of problems in Florida with Ian. The evacuations might benefit, of course, from operations that could improve traffic flow. Contraflow is very effective at helping get folks out of the affected areas, but it takes a lot of time to set up. So some of the questions that we would like to run through a scenario analysis would be, for example, can we use variable speed limits to smooth the traffic, particularly around interchanges where a lot of folks are coming onto those outbound interstates and trying to move on? Or can we add hard shoulder running if contraflow is not available for whatever reason? We also found that many data flows become unavailable, and that creates some problems. Obviously, during hurricane conditions, we get a lot of field sensor outages, not just traffic cameras, but even speed sensors that are either blinded or potentially underwater. And even some of the data services can become unreliable when you have such a huge demand and they're losing their own data sources. Of course, that kind of blinds operations during the event, but also in the recovery phase. What we get concerned about is that data needed for monitoring and for recovery may not be available, and in fact is not necessarily the same that we need for normal operations. And then, of course, as you wind down from that, after you've gotten through the recovery, we have lots of questions to ask about resilience and how can we improve the resilience of the system. Are there things that we can learn from having these kinds of detailed records of these storms? All right. I am going to give other folks a chance to talk for a while. And Michelle, I think I'm back to you.
Yeah, thanks, Kyle. Next, we have Bob Sanchez. Bob Sanchez has been with Leidos for about 30 years. He's got a lot of research and development experience that includes planning and conducting independent national evaluations of intelligent transportation systems, developing measures of effectiveness, and reporting on findings for various innovative technologies and processes. For IMRCP, Mr. Sanchez led the evaluation activities and reported officially on the results and findings. Bob, it's all yours.
Okay, thank you, Michelle. Go ahead and go to the next slide. I've got a couple of slides here, and I'll just share with you what we did for the evaluation. This first slide talk about, just at a high level, the approach we used, and then the next slide talk a little bit about the findings, and then end it with having Lucy Kimbang talk about her experiences and perspectives from Louisiana DOTD point of view. For our evaluation, we did one in Ohio and one in Louisiana. The Ohio evaluation took place end of December through about April of 2022. And then we followed that up with the Louisiana evaluation, which was May through about August. In both cases, both evaluations, what we looked at were the accuracy of IMRCP, as well as exploring, some of the user experiences and perceptions and perspectives about the system. For the Ohio evaluation, we took a look at the accuracy of the IMRCP speeds and pavement temperature predictions, and we did that at 2 locations, one near Cleveland and one near Columbus. We, again, as Kyle had explained about the January 16th and 17th winter storm, we used that time period and analyzed that data to try and look at the accuracy of the IMRCP predictions and forecasts. So, in addition to that, in Ohio, we wanted to explore the user experiences and their perspectives. And what we did in that case is we spoke with folks there through questionnaires, interviews, and discussions, telephone discussions, to try and get at their thoughts about the system, how it might be useful, that sort of thing. In Louisiana, again, we looked at the accuracy of the IMRCP speed predictions and forecasts, and we also looked at some of the road condition predictions, see how well that worked. In Louisiana, we looked at 2 locations, 2 near New Orleans and 2 near Baton Rouge. And that's where we kind of focused our attentions on certain road segments there. For the analysis, we looked at the Hurricane Ida data, and that was the August 28th through 30th data that Kyle had talked about earlier. In addition to the accuracy of IMRCP speed predictions, we also looked at user experiences and perceptions. And for Louisiana was a little bit different than what we had done in Ohio for this user experiences part of it. What we did is we set up a number of sessions where we had Louisiana DOTD folks come in, and we walked through very carefully a series of activities and tasks. And so Lucy was one of those participants, and we had a variety of folks. Some were administrators, some were managers, some were engineers. And we had them come in for these 90-minute guided sessions. And as they walked through each of the tasks, we would go ahead and stop momentarily, collect ratings, and try and get feedback from them about their thoughts about the interface, about how this could be used on, from their perspective, things like that. So we were able to collect a little bit more in-depth information out of the Louisiana folks. And the walkthrough proved to be a very effective method for getting folks to, look at IMRCP, kind of exercise the system and see what they thought about it. During these walkthrough sessions, we selected again that Hurricane Ida timeframe. So we had it all scripted out, and we knew exactly what steps they would take. And it was we got a lot of good results and findings from that activity. Can we go to the next slide, please? Thanks. So evaluation findings. In terms of the accuracy, in both cases, when both Ohio and Louisiana, when we looked at the reliability of the speed predictions and forecasts, they were generally pretty good. It was also the case with the pavement temperature as well, that when we looked at pavement temperature up in Ohio, those worked out pretty well. They pretty well matched up what we had seen from the real data, the actual data. Let me see the second. The speed predictions. We also looked at doing forecasting in 15 minutes versus 30 minutes versus 120 minutes, that kind of thing. How well the IMRCP system predicted or forecasted future speeds. And for the most part, again, it was pretty good. One of the big, maybe it's the obvious finding was that more nearer term predictions tended to be more accurate than the longer term predictions or forecasts. And of course, that kind of gets back to the third bullet there, and what Kyle had mentioned earlier, is that since the MLPH machine learning program model learns from historical data, some of the basically the model could probably benefit from having, would be more accurate in terms of the speed forecast and things like that, as it would learn from more historical data. So more data is better. The machine learning model learns from that data and is better at doing these predictions. So not earth shattering, but it proved to be something that we kind of did see with these longer term forecasts and that. In terms of the user experiences and perceptions, part of what we found, both in Ohio and Louisiana, is that in general, the forecasts, the opinion was that the forecast can be helpful to anticipate, the changes to traffic and weather conditions that may be coming as a result of either winter weather or tropical storms. Folks tended to have a very favorable, opinion about the usability or utility of IMRCP and the forecast for speeds and pavement conditions. Also, the second one, the weather and pavement conditions, folks tended to agree that it was a valuable asset of the system and could be used to monitor the icing conditions and be helpful for decisions regarding treating the roads and that sort of thing. From the walkthrough results with the Louisiana participants, based on ratings and discussions and things like that, all of the participants agreed that IMRCP was definitely easy to use and easy to understand. Most agreed that it could be useful for decision making, and although they had a number of we had a variety of users sit down, and one of the things they had a lot of opinions and a lot of suggestions on user interface issues and things that could be improved that they thought would be helpful in their role and their responsibilities. And that was an interesting thing, is because we had a variety of staff participate in these walkthroughs. They all had a different perspective on the ways that it could be useful to them and support their work. And so there's a lot of good suggestions. We have an evaluation report that's being wrapped up. There were a lot of good insights and perspectives and suggestions for improvement and things like that. But it was probably most enlightening to hear from the different staff how IMRCP would support their role and responsibilities. And let's see, I think with that, I think it's probably a good time to go ahead and turn it over to Lucy and have her talk about her experiences and her perspectives about the system. Is that okay, Lucy?
Yeah, thanks, Bob.
Sure.
I know we already heard from Scott. He had to leave unexpectedly a little bit early. But yeah, Lucy Kimbing is the ITS program manager with the Louisiana Department of Transportation and Development. She has worked for Louisiana DOTD for about 14 years and has experience in district traffic operations, state roadway maintenance, and ITS. Lucy, tell us about your experience using IMRCP in Louisiana.
Yes, good afternoon, everyone. And fortunately for us, this hurricane season, we did not really have any major weather event that came through for us to test the system with an actual event that is happening or verify the predictions of IMRCP. But we had a training on how to use it and had a walkthrough that was really detailed on an individual basis. So I thought, let me express my own perspectives and view of this program, this software. I thought it is a really useful tool to be added to all the other tools we have in our toolbox when it comes to emergencies. And I thought this could really be useful in planning for resources. So if an emergency is declared, generally, we determine like additional resources that we need to have in place to be able to handle the weather situation, such as, do we need additional TMC operators, or do we need additional safety patrol trucks to patrol? So with this, with IMRCP, it would tell us how bad the situation it's gonna be, and maybe if we have road closures or we have to close the ramps, or maybe which other arterials would be open and where we put those resources. So I think that would be a really good planning tool as to resources that you need during a weather event. Also, this could be a useful tool for our emergency operations centers, because that is where, like our ESF3, that is where they do the declarations, and that is where maybe they close everything that is weather related. So this could be a very useful as it provides granular and detailed information on the actual pavement conditions during weather events. And for our area engineers and our district traffic operations engineers, they are responsible. They are the ones that actually put out the orders to have roads closed or to have ramps closed. And even when the event is over, like to open the roads or to open the ramps, they are the ones who make that decision as to closing the roads, closing the ramps. And for us at the TMC, they send that information to us for us to feed it to the 911 system or post those messages on the dynamic message signs on the road. So this software would help them to actually determine, let me say, if we have an ice storm, and then they could go in there to predict what would the pavement temperature be, maybe in the next 3 hours or in the next 5 hours. If it shows that maybe the ice on the ramps or the elevated portions, because we have that problem in Louisiana, as we have a lot of elevated pavement in concrete. So once we have an ice storm, and in Louisiana too, because those are rare happenings, we really don't have all the resources like maybe salt, sand, and all the trucks that other states in the north have. to handle winter and ice situations. We really don't have those. So for us in Louisiana, we mostly close our interstate on and close the ramps until when it heats up a little bit and everything melts, and then we open them. So usually the district traffic, the area engineers and the district traffic operation engineers, they are the ones who are responsible to determine when to close them and when to open them. So if they have this tool and they use it to predict maybe in 5 hours what the temperatures would be, or if maybe in 5 hours the ice would have melted, then they could then send the technicians, because even before they open the roads or the ramps, they have to send technicians, or they themselves have to go out there and drive it and make sure that it's safe enough to open it to the public. So this could be a tool to help them determine or be able to know that maybe in 8 hours or the roads will be closed for the next 10 hours or so. That would be a good information for them to know. And then also I thought this could be actually a lifesaver when it comes to major incidents during inclement weather in after action reviews. So we could use this to go back, as they said, you could forecast, you could go back 5 days or forecast 5 days forward. So you could go back within 5 days to determine what the actual condition, road conditions were, traffic conditions were, speed conditions were out there when that incident happened. Because if it's a really major incident, then we end up with like lawsuits, or we get deposed and stuff like that, because somebody may say that, oh, you guys opened the ramp or opened the road when it still has ice on it. And this could be a useful tool to provide backing that, no, when we opened the road, this were the conditions. And for real, it was not ice, maybe it was another cause, something else that caused the accident, not because we opened the road when we were not supposed to open the road. So hopefully, if we have another event in the future, we would like to actually use IMRCP, use all the predictions, and then compare it with actually what happened. And I believe when we do that and it comes out to show that this was an actual event and the accuracy level was really good, maybe different sections or different people within the department may see it useful and be ready to use it. So that is the little that I have to add to this one.
Yeah, thanks, Lucy. That was great. Now we're kind of winding down towards the end, and I think there's just one small other section here that Kyle was going to go through regarding deploying IMRCP.
Yeah, thanks, Michelle. Just to give some perspective to how this could be useful, not just to those who are involved in the FHWA effort and the projects that I've described, but we're looking forward to other deployments in the future. IMRCP was built around existing data sources and forecast methods for the most part. And it's all developed under an open source license with USDOT. All of the weather and hydrological data collection is built into the code. It does require some deployment customization though. The biggest lift is probably the network model. There's an IMRCP tool for doing that, but it still depends on settings and configuration and cleanup. Local data sources, especially if you're looking at traffic data, hydrological data, operations, those need to be configured or in some cases may be developed. And then of course it has to have traffic models. The traffic models rather have to be trained. So there's a large archive of data that has to be attached to it to get to that. Next slide, please. In terms of deployment activities and resources, the process would look something like this. Number one, you have to know what it is you're trying to build. So you'd have to gather the stakeholders. There is a significant computer infrastructure that goes into that. As I said, building the road model, the network, the traffic model, all of the data collection. There's a calibration piece. And of course, there's the, making it familiar to operators so that they can actually use it. If you're interested in the system and its documentation, it is available on the open source application development portal with USDOT. That's a GitHub portal, and you should look for IMRCP. There's documentation out there, installation administration guide as well. We are just now in the process of deploying the code that was developed for phase 4. So that should be showing up later this week. And one last slide, I think. And I'm just going to take this one, Michelle, if that's all right. And then we want to leave a little bit of time for questions if you have. So we've talked a lot today. Hopefully it's been instructive and helpful and entertaining at times even. We believe that IMRCP over the course of its development has really demonstrated the ability to extend awareness from now to what next. And in particular, in this most recent phase, we've looked at it in applications and scenarios for winter storms with Ohio DOT and with tropical storms, to the extent that we were able to look, at least in hindsight, back to Hurricane Ida. Future deployments are going to will partner with state agencies, especially for tropical storms and extreme weather events. It's become clear that this is an emerging area of interest that doesn't just affect, by the way, the coastal regions. A lot of you may remember that Hurricane Ida actually spread very heavy rain all the way up the Appalachians, even into the mid-Atlantic and the northeastern states. And in that case, we'll be looking at things like resiliency and risk, planning for evacuations, real-time support, storm surge, as we've seen in Ida and Ian, is a huge deal. And we want to take better advantage of the information that's become available there. I think that's all we have. Next slide is contact information. And following that, I think we're going to open up for just a few minutes for questions.
I noticed that some people have typed some questions in the Q&A, and I know Kyle has already got in there and provided some answers. But does anybody else, on the line have any questions that they'd like to ask Kyle, or anybody on the webinar? Let's see. Kyle,
Michelle,
I think there's...
Yeah, I was just going to say, we have a question in the Q&A that I'm just going to answer live here, I think. Commons connections to Claris and the work that we did there. Some of you may remember the Claris system, which went online back in, the early 2000s and has transitioned since then into the weather data environment. That system collects information from RWIS all around the country and puts it into an archive form that we can go grab. IMRCP, in fact, uses the WDE archives to set up the initial conditions for its forecasts. So yes, it's used.
All right. Well, we're kind of winding down. We got 1 minute left, so I think I might use this time just to thank all the speakers today, and especially Scott and Lucy for joining us, and everybody else from your agencies that were involved with using and testing IMRCP. I know you guys were volunteered your time. You guys have extra duties, on your plate when you get involved in that. So I really appreciate all the valuable insights that you guys have provided. Thanks everybody for attending this Road Weather Spotlight on IMRCP. I think this may conclude our webinar. Thanks, and hope you guys have a great day.
Yeah, thank you. Same to you.